It is Thursday. We're at nearing the end of week 6, day 12. A couple more weeks, be it midterm, or a week or so. A couple things going on. This is Networking Essentials, addressing and collaboration. They did on students, you guys did on Tuesday, and then we got IP addressing. Start talking about subnets. But first of all, Tech Den tomorrow, Friday, starting at 10 a.m., doing some wiring and punch downs. Make sure you make an appointment for registering either for winter or spring. You make an appointment and do that with Ryan Johnson. In the counseling services. First of all, students, we talked about cell phones. Why they call them cell phones? I don't know if anybody ever knew, but I'm not sure exactly what the cells look like. But in reality, we have cells. Then inside those cells we have these towers. Maybe one per cell or multiple ones in the cell. So those are towers. And then you can have, let's say you're driving along, you make a phone call, so you connect to a tower. Now inside each one of these cells there is a finite number of frequencies. So you get a particular frequency. And then when you drive into another cell, you get a new frequency. Because we have a finite number of frequencies for in the cells. That's why we call them cell phones. So if you're downtown New York, the cells would be real small. If you're out in the middle of Montana, the cells would be real big. So we just divide things up by cells. Another thing we talked about, a couple of the students couldn't figure out how to access their websites. What they should have done last Tuesday is they should have asked another student. I thought I made it clear that the assignment had to do with collaboration. So part of that is collaborating with the students around you. I actually told you what your groups were, and there shouldn't have been anybody not be able to open their website. So today we opened them, and we use this address to access the server. It's a private IP address. Now that private address is tied to, I'll just use another color here, a public address that's used out on the internet. Now we could take this public address and look it up in Aaron, and it will tell you that that address there is being used by NIAC. And so I believe this one is too. And those are public addresses, and it can be used on the internet. Let's talk some more about that. We did quite a few examples here. Let me just back up. We talked about collaboration and finding answers, especially when half of the work was actually called collaboration. So when you're stuck, part of the advantage of being in a face-to-face class is you have other people that you can use as resources. Okay. So here we have the private address, access a server. If you're going to access it from the internet, you would use this public address, and they're tied together in the firewall. Actually, learn more about that later. Here are the private addresses, all of the 10s. And then for some reason they split the 172s up, 172.16.00 to 172.31.255, 255. And this Class C address is a private one, 192.168. Back in the olden days, this was a Class A, this was a Class B, this is a Class C. Most of that's going to disappear in the near future. Okay, I connect to the internet with my iPad, and I got this address. Now, part of the reason that address is different, this is my address out on the internet. Okay? Part of the reason that's different is because I connected my iPad to an access point. And it goes out through the main college network, so it's using a different public address, even though this one belongs to NIAC also. Well, this is one NIAC can use also. Where do you find that? You find it on aaron.net. So, when we did a little research, we found this range of addresses are being used by NIAC, plus some others. Okay? /24, and we talked about this, but reiterate that. 24 bits. There's 8, 8, and 8. That's 24. That part's the network. Nobody else can use that, and we can't start changing that. That's part of the network. Now, in the IT area, we have this network and this network, and we can use those addresses. Now, what do we do with those addresses? Well, here's an example. We assigned this one to a particular server. So when you're out on the internet and you access that, that'll connect to the private address internally and take you to the server. So we can manage these two. Why they're split, I don't know. I don't remember exactly when we had all these addresses assigned, but these two are assigned to the academic IT. So when you're out on the internet, okay, here we are, okay, so let's say we're at Cabin Coffee. Okay, we connect into the internet. We're going to one of these two addresses. Maybe we're going to this server right here. It routes us through the internet, sends us to the ICN. The ICN knows it belongs to NIAC. When it gets to this routing device, it knows to send it to the academic IT because of if it's either one of those, it sends it down here. If it's anything else, it sends it over there. Now, we looked up some other addresses. For example, we got this address. I think that was the address on the iPad. Now, didn't I tell you we had an address down here for the iPad? This one's the public, and this one's the private. And then it gave a mask, which would be, this is the 248. So if we were going to rewrite that address, it'd be 10.10.1.18 slash, here's 8, that's another 8, so that's 16, 17, 18, 19, 20, 21. So this would be a slash 21. 21 bits make up the network part of the address. And in there it said this was a router, so that's actually the default gateway. Almost. So we talked about the example. You have a private address at home. You do network address translation to convert it to a public address to use out here on the internet. And who do you get that from? Your internet service provider. We had an interesting scenario. So then here we then did some packet tracer work. Looked at examples there. I don't have that in the video here, but they have a PC set up, then a network device, and over here like a web server. So they want you to ping the web server, and the first one timed out, and then they were good. And we were trying to determine, why did that first one time out? Well, the PC, when we pinged this web server, we had, I'll write another color, we had an IP address. But in order for this device to talk to this networking device, we have to have a MAC address. So what the computer did was it did an ARP, sent a broadcast, and said, who has this IP? Well, nobody on this network had it, but what the PC did then, it said, well, now for us to connect here, we'll use our default gateway to go to this device, which will then go to the web. And so it did an ARP. This sent back its MAC address. Then it got the traffic ready and sent it to the networking device. It got to the web, and then it sent the pings back. And we talked about how to submit a packet tracer file. Alright. So, the last thing we did, we talked about hexadecimal base 16, which has 16 digits. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So hexadecimals would be one of these digits plus one of these letters. And then we did a short example. We had, I think, FB. So B would be 11, right? This would be 10, this would be 11. And F would be 16. So to get 16, we have one group of 8, one group of 4, one group of 2, one group of 1. Actually, that would be 15, right? Because we have 0 up here. My bad. So this would be 15. So it would be 8, 9, 10, 11, 12, 13, 14, 15. Then a B would be 11, so that would be one group of 8, 9, 10, 11. We have 0 groups of 4. And then the last thing, we'll talk more about hexadecimal. And the last thing I showed the calculator. We typed in FB here on the keypad, FB. So in hex it's FB, in decimal that's 251, octo 373, and in binary 1111, that's the F, and 1011, that's the B. You need to know how to work with the bits in terms of binary to decimal. You should be able to do that by hand, and eventually we'd be able to do this, the hexadecimal to binary, by hand, but we can use the calculator to check. Sound fair? That's it.